Hey everyone, today we'll be solving LeetCode problem number 2971. Find polygon with the largest parameter. Okay, let's try to have a look on this problem statement. In this problem, we will be given an array of positive integers nums of length n, and they have given some definitions. A polygon is a closed plane figure that has at least three sides, and the condition it should follow is that the longest side of the polygon is smaller than the sum of other sides. This is just a formula representation, and they're also saying that perimeter of a polygon is the sum of length of its side. Okay, what they are saying is that we have given a polygon and their lengths are given to us, and what we have to find out is the largest possible parameter of a polygon whose sides can be formed using nums. So these sides are given in the nums array, and first of all, if it is a polygon, then the largest side, let's say this is the largest side. If the largest side value is less than the sum of all the smaller side sum, in that case it can form a polygon. Let's say if we were given 9, 1 and 20. If we were given the sides like this, so let's say if I draw 9 and if I have to draw 1, so 1 can you draw in any direction, then 20 we cannot accommodate 20 to these two edges, so we cannot form a polygon because the largest side is 20. 9 plus 1, that is 10. Largest side is not less than 10, so we cannot form a polygon. So this is a condition to be a polygon. And what is the parameter of polygon? Parameter is nothing, just the sum of all the sides. So this is what is given in the problem statement, and what we have to find out is the largest parameter of a polygon possible using these nums. So what are these nums? These are nothing, the sides of the polygon. Let's say these are the length of the sides, and we have to figure out the largest parameter of a polygon. If we have to choose a subset of these lengths, and we have to maximize the parameter. And now it is clear to us that parameter is the sum of all the sides in the polygon, and the edges can make a polygon only if the largest edge is less than the sum of all the smaller edges. So from this nums we have to choose k edges. Let's say we can also choose all the edges, but we have to check all the possibilities. Let's say we have chosen k edges, only k sides are forming a polygon. So in that case, let's say this is the order of the edges. Let's say a1 is the smallest edges and ak is the biggest edge. So the formula it should follow is the biggest edge, ak is the largest edge, it should be less than the sum of all the smaller edges. If it is following this condition, then it is a valid polygon and we can capture the parameter. Parameter is nothing from a1 to ak, the sum of all the edges. Now we have to take out the edges in such a manner that we get the maximized area. So we have to check all the possibilities. If we have to check all the possibilities, we should be having the values in this form: a1 less than equal to a2 less than equal to a3 less than equal to a4. So if we want the edges in this form, so we have to definitely sort this array. And if we have sorted this array, the second thing is we can check for all the possibilities. We can check all the possibilities where we are getting edges as a polygon edges, and we can capture the parameter. So here in this way I'm going greedy. I'm being greedy because as per the statement I'm following our problem approach. Okay, I hope the problem statement is clear to you, that these are the edges of a polygon and these are the edges length, and we have to form a polygon with subset of these edges such that the polygon parameter is maximized. So here we will go greedy. So first of all, we have decided to sort this array because we want edges in this form. We want the biggest edges and the smallest edges sum we will get. So if I sort this array, what will it become? 1 1 2 3, 1 1 2 3, and then 5, then 12 and 50. Okay, we have sorted this array. Now what we can do is I can check all the possibilities, because these edges are in the form of like this: a1 less than equal to a2 less than equal to a3 less than equal to ak. And we are also given that the polygon have at least 3 edges, because only in that case it can form a polygon. This is the smallest polygon, smallest number of length in the polygon. So first of all, like, we can see this as a polygon. So here this edge should be less than the sum of all the previous edges. Okay, so this is the least possible polygon in this case. So 2 is the biggest side length should be less than the sum of all the smaller side lengths, which is 2. 2 is not less than 2, we can discard it easily. So it's not a valid polygon, so we will not capture it. Now what we will do is we will check for other possibilities. This is 3 length polygon, and now we will see 4 length polygon. So for the 4 length polygon, we are at this 3. So now this 3 should be less than the sum of all the smaller sides. So all the smaller side sum is 1 plus 1 plus 2, which is 4. So 4 greater than 3. Whether it is true or not, yeah, it is valid. It means this 1, 1, 2, 3 can form a valid polygon. Okay, so now in this case, what we have to capture is sum of sum of the parameter. So parameter sum is 4 plus 3, 7. So 7 is our possible answer of polygon of size 4. Now we'll try to expand all the other options as well, because we are going greedy, and we will check all the bigger like possibilities. Here it was a 4 length polygon. Now we'll check for 5 length polygon. For the 5 length polygon, the biggest side is 5. So the biggest side 5 should be less than the sum of all the smaller side. All the smaller side sum is 7. We already calculated. So 7 is greater than 5. So yeah, this is also valid. So parameter for this polygon is 7 plus 5, which is 12. So 12 is bigger than 7, so 12 is our new answer. Now we'll try to expand the polygon, which is 12. So 12 is greater than 12. No, it is not the case. And now 24 greater than 50. If we are here, no, this is also not valid. 24 is not greater than 50, so we'll discard it. So maximum parameter we have captured so far of a polygon is 12. So 12 we are going to return from the function, and that is going to be our answer. So here what I did is, so for to check the polygon of length 3, I need the sum of first two elements. For the capture to capture the parameter of polygon of length 4, I captured this much element. That is, for a polygon of number of sides is 4, I want sum of all the smaller sides. So it means we can maintain the sum prefix sum in this case. So polygon till this, we want the sum of these two elements. Polygon till this 3, we want sum of 1 1 2. Polygon till this 5, we want sum of 1 1 2 3. So here I got the idea that I have to maintain the prefix sum. So first of all, I did the sorting, and then I maintained the prefix sum, and I will keep on checking for every index I greater than equal to 2, because polygon is of length 3. Polygon number of sides in the polygon is should be minimum 3. That's why I'm starting with 2. So first polygon will be at this 1 1 2, then 1 1 2 3, 1 1 2 3 5, and so on till this 50. So whenever we will capture the maximum parameter, we will be storing that in a separate variable. Okay, I hope this approach is clear to you. So what is the time and space complexity here? As first of all we did the sorting. So sorting itself is going to take n log of n time. After that, we are iterating over the array on time. So overall, it is going to be O of n log n. This is the time complexity. And what is the space complexity? First of all, we using sorting. So sorting algorithm itself is going to take some time. So let's say I'm using an inbuilt function of Java to sort this array. In that case, it is going to take log of n space. I'm considering space from quicksort. You can check over Google. So this is the time and space complexity of this approach, n log n and log n. Okay, now let's quickly code this problem. First of all, I need to sort this array, arrays.sort nums. Let me also capture the length. Now I have to check all the polygons in this array. That is polygons of length 3 till the length of n. So first of all, let's start with the length 3. For I equal to 2, I less than n, I plus plus. For I equal to 2. Here, first of all, we need to maintain the prefix sum. So prefix sum can be too large. So I'm taking a long array and long variable and long variable to store my answer. Let's say it is -1 in the starting. So sum should be for the first polygon that is ending at I equal to 2. The sum of all the smaller edges would be nums of 0 plus nums of 1. Okay, now it's clear. So first of all, I will check for the polygon of length 3. Here, sum is the sum of all the smaller edges. If that sum is greater than the nums of I, it means it is a valid polygon. If it is not the case, we'll check for other possibilities. That is updating my prefix sum plus equal to nums of I, and I is incremented in the for loop. Okay, but if it is a valid polygon, we will check our update our answer as all the sides are in the positive form. So every answer we will get after some time, we will be that will be larger than the previously captured answer. Okay, because more number of sides are involved in this answer. So answer will be updated to sum plus nums of I. Answer is our long, so to avoid the overflow, because the return parameter is also long. Okay, now I think that's all I have to code. Now if I try to return answer and test over sample test cases are passed. I'm submitting the problem. It got submitted successfully. Hope you understood the problem. Thank you guys.